Okay, so this video we're just going to go over an example where we're doing log differentiation. All right, so the example here is find y prime for y equals to the square root of x minus 1 over x to the fourth plus 1. Okay, now in a previous class, right, or the previous semester in Math 1, we would start off by doing the chain rule right inside the square root, and then we'd have to do the then multiply that by the inner function, which now requires the quotient rule. All right, now that can be very involved here, right? So what we're going to do here is just lean on stuff that we've already learned, right? So here's another approach to this problem, right? The approach would be to start by taking the natural log of both sides. Right, so we'll get something like natural log of y equals to the natural log. And here I'm going to rewrite this as an exponent, rational exponent notation to the 1/2. All right. And the reason being is because we have some very helpful properties here for the natural log, right? It changes exponentiation into a, excuse me, into constant multiplication. And then it splits division into subtraction. And that's going to be very helpful here, right? That bypasses having to use the chain rule, or at least a more complicated chain rule, and the quotient rule, right? Because now, using all the properties of the natural logarithm, here, I can rewrite this. Natural log of y is still natural log of y, but here we have 1/2 natural log of x minus 1 minus natural log of x to the fourth plus 1. Okay, and now let's go ahead and let's try to take the derivative of this, right? And we'll see this is much more straightforward, or a little bit less painful than the original function that we started with. Now, we also need the idea of implicit differentiation, right? Because y, as we've seen above, is a function of x. So when I take the derivative of this, of the left side, it's 1 over y, chain rule, derivative of the inside is y prime. Okay, and then in here, we have 1/2. Derivative of ln of x minus 1 is 1 over x minus 1, minus here, x to the fourth plus 1. Here we need the chain rule, right? Derivative of the inside is 4x cubed. Right? We didn't need it here because, well, the derivative is 1. So when we use it, we just get the value of 1. All right. And now here solving for y prime, we get y prime is equal to y over 2, 1 over x minus 1 minus 4x cubed over x to the fourth plus 1. All right, where y, again, careful here, y is this function up here, right? So if you want here, just to, for sake of completion here, we get 1 over x minus 1, x to the fourth plus 1, excuse me. Okay. All right. And notice here, I think much more straightforward, less painful than if we didn't have this logarithmic differentiation available to us. So here's a nice kind of result of the natural logarithm and its properties.